This is lesson 5.2. We're talking about special products. It means we're going to learn some tricks and some patterns for multiplying polynomials. Okay? It's going to make things a little bit simpler for you if you can remember the patterns and you can understand why they work. First thing I would like you to be familiar with, in your review column, you can write square numbers. Not squared numbers, square numbers. Did you know that numbers could be square? I don't know if there's any round numbers. I suppose any whole number would be a round number. Triangular numbers. There are also triangular numbers.
Yeah, let's see you draw it.
Okay. And the next one is, well, let's just talk about this. What are some square numbers? Anyone heard about that before?
No.
A square number?
No.
I'll give you a hint. Number 1 is a square number. So you can go ahead and write that in your first blank. Number 1 is a square number. Do you want to guess any other ones?
3.
4 is a square number. Is 3 a square number?
No.
Nope, don't say why yet. I want you to think about it. 4 is a square number. Jonathan, what's the next square number?
6. 8. 16.
Wrong.
8.
Tanner?
2.
Wrong. Lindsay?
9.
9. Isaiah, what is the next square number?
14.
No. Paul? No. Vlad?
18.
No.
16.
What?
16. Emma, what is the next square number?
They don't fit. You don't fit.
No. Jonathan? 25. Emma, what is the next square number? Paul?
36.
36.
Where are you guys getting these numbers from?
Isaiah, what is the next square number?
48.
No. Close, your multiplication is wrong.
49.
49.
What? Oh yeah, never mind.
Oh boy, oh boy.
They can be squared or square root. How? The square root of 4.
Is what?
9. What's the next one? 15.
Okay, let's talk about square roots.
64 is the next one?
Do you know what square roots are?
Yeah.
Square roots are a number that when you multiply it by itself, it becomes a square number. So a number that you multiply itself and it will become a square number. So if I take 1 and I multiply it by 1, I'll get 1. What's the next square number?
2.
Or square root, sorry.
4.
2, good. What's the next square root?
3.
What's the next one?
4.
You guys are just counting by ones.
The next one is 17.
6.
Okay, do you know what a square number is now?
Yes.
Okay, a square number, they're special numbers because they are the only numbers that can be made by multiplying a number by itself. So any number times itself equals a square number.
Yeah, that's everything.
No.
No.
Next one will be 64, right?
Yeah.
Next one would be 64.
What? I don't get it.
81.
Then 81.
Oh, you're talking about the
And
top one. Yeah,
then 100.
top
Then
one.
121. Then what?
I don't know.
139. Then what?
I think I know.
144. Then what?
160? 162.
Let's carry on.
We'll carry on counting.
Okay, so that's what you need to know. We can also deal with this in binomials. So for instance, if you had a binomial, a plus b, and you multiplied it by itself, it becomes a perfect square trinomial. More about that later. Everybody look at this picture of the square that I've given to you there. If a square has a side length of 5 centimeters, then what is the area of the tile?
25.
Because we go 5 times 5 equals 25. So we've got 25 centimeters squared, or 25 square centimeters. Either way. Now, what if that square tile has a side length of x?
X squared.
Now we have x times x, which equals x squared. Way to go. But what if the side length isn't 5, some value, and it isn't x, some unknown value, it's x plus 3. Now what do we do? It would be x plus 3 times x plus 3, which we'd have to FOIL, but not after today. You're not going to have to FOIL it. Okay, we're going to leave that one alone. We're going to come back to x plus 3 squared in just a moment. It looks like this, x plus 3 squared, but that's not really a good enough answer. That's not simplified. It's not expanded. So we'll get to that in a second. Look down to the next part of your sheet. I've given you 4 examples there that are already answered. X plus 2 squared, and I've told you what it equals. X plus 5 squared, I've told you what it equals. 2x plus 4 squared, and 4x plus 7y squared. And you have the answers there. Those on the right are perfect square trinomials. Trinomials, why are they called trinomials? Because it's a polynomial with 3 terms. Good. On the right are binomials squared. Does that make sense to you? Sorry, on the left. Good call. Binomials squared, because there's binomials. X plus 3, that's a binomial, and it's squared to the power of 2. So you have a binomial squared, and they equal perfect square trinomials. We're going to write a note about that later. Okay, analyze those, please. Look at the left side and the right side of each one. Try to think if there's any connections that you see or notice. I'm going to give you something specific to look for. How is the first term in each trinomial related to the first term in each binomial? It's just squared. Good. So it's the square of the first term. Let's do it this way. The first term of trinomial equals first term of binomial squared. So if you look at the first term of A, that's in that binomial, the first term is x, and x squared is x squared, and that's the first term in the trinomial. If you look down at D, you've got 4x as the first term in the binomial, and if you square that, you get 4 squared x squared, which is 16x squared, and that's the first term in the trinomial. Good. How is the last term in each trinomial related to the last term in each binomial? Same rule. Last term of trinomial equals last term of binomial squared. So we're noticing some patterns. But now in the trinomial we still have that middle term. Where does that come from? How is the middle term in each trinomial related to the terms in the binomial?
Doing outside and inside doing form.
Okay. Good. So outside, inside on the FOIL, right? If you're foiling, you got first times first, last times last, and then you've got outside times outside and inside times inside. So really all that is you're taking both the terms of the binomial, multiplying them together, and then timesing it by 2. Go ahead and check if that's true in A. If I take x and 2, I multiply them together, I get 2x. I multiply that by 2, I get 4x. Did it work? Let's look at C. The first term in the binomial is 2x. Second term is 4. So if I do 4 times 2x, I get 8x. And then I multiply that by 2, because I'm going to get it twice. If I'm foiling, I'm going to get it for outside, outside, and inside, inside. And that'll be 16x. Same thing occurs in D. 4x times 7y is 28xy. If I do that twice, I'll get 56xy. Pretty cool, eh?
Yeah. Really.
Okay. The middle term is equal to is equal to the product of the two terms of the binomial and 2. It's the product of the two terms of the binomial and 2. So that means you're taking one term of the binomial times another term in the binomial times 2.
How do you use times each one?
Number 4. Think of a rule. Think of it. Don't write it. Just think about it. Think of a rule for expanding and simplifying a plus b squared. It's going to equal a trinomial. What do you know about that trinomial? Think about what the first term is. The first term of the trinomial is equal to the first term of the binomial squared. So all we're doing here, the first term of the trinomial is equal to the first term of the binomial squared. Right? That's what it says in the green words. Well, let's look at our last term in the trinomial. It says the last term of the trinomial equals the last term of the binomial squared. So what goes in this last blank? B squared. It's just the last term of the binomial squared. Boom, there it is. What about this middle one? The middle term is equal to the product, that's multiplication, of the two terms of the binomial. That's right here. Here's one term, here's another term. Times 2. Not squared.
Times AB squared.
2ab. There's no squaring. Okay? There's no squared in multiplying a times b. Is just a times b. ab. Right? Not a squared or b squared, just ab. And multiplying it by 2 means you have ab twice. 2 ab's. Yeah? Good. Scan down to the next section there. It says, consider the following binomials and their simplified trinomials. Now, how are the binomials in the second part different from the binomials at the top part of your page? Okay, these binomials involve subtraction. They're in the form a minus b. So go ahead and analyze the binomials and their trinomials. Jonathan, how is the first term in each trinomial related to the first term in each binomial? It's just squared. Good. Tanner, how is the last term in each trinomial related to the last term in each binomial? It's just squared. Good. 7. How is the middle term, Isaiah, how is the middle term in each trinomial related to the terms in the binomial?
It's just x minus 3, which is minus 3x squared.
Somebody else want to try?
It's the
Close, but...
outside and inside multiply.
Okay, so you said that one last time, and then we developed it into a different statement. Can you remember the new statement? So you're right that it's outside and inside if we're thinking of it as foiling, but it's outside and inside together at once. We got to put them both together somehow, right? So we're multiplying the first term of the binomial by the second term of the binomial, and then we have that twice, so we multiply it by 2. Okay? Well, can you go ahead and generate a rule, please, for a minus b squared, and it's going to be some kind of trinomial.
You said don't write it. You said don't write it, just think about it.
Yep, think about it. So what happened? How did we get this first term?
We squared it.
Yeah, it's just the first term over here squared.
So a squared.
A squared. How do we get the last term?
B squared.
B squared. And in between?
Minus
2ab. Right? But this is going to be a subtraction sign. This is going to be positive. Again, you don't need to write that because we're going to write it on the next page, I think.
More algebra.
Okay, we're going to solve x plus 3 squared in a few different ways. The first one is algebra tiles. So how do I set up my grid for algebra tiles? If I have x plus 3 times x plus 3.
One X and 3 little squares.
Yeah, I can kind of think of this as a rectangle, right? Where the side lengths are x plus 3 and x plus 3. So it's actually a square. So up here we're going to have x plus 3. And down here we're going to have x plus 3. Those are called our factors. X plus 3 and x plus 3. And in the middle here we're going to have our product, because we're going to multiply our factors together, which means I need to multiply all of these parts by all of these parts. Let's start with x times x. Yeah, we can just look at the shape. It's going to take up this much space. Basically all we're saying is if we had a side length of x and a side length of x, then the box that they make would be this big. Well, now we've got x times 3. So we've got 3 x's to draw. And coming down this way, we have x times 3, so we have 3 x's to draw here. And then we're just left with our ones. What do we got? Yeah, 9 ones. And we're going to draw them all out. Good. So that shows us that x plus 3 squared equals x squared. How many x's?
6X.
Plus 6 x's. And how many ones?
9.
Plus 9.
Is this probably new?
Let's do it using a grid. So a grid is a little bit different way of thinking about it, but the same thing happens. So basically all you need to know is you got to think of, okay, let's say x is this long and 3 is this long. So we have a little bit of a divide there. This length is x and this length is 3. And we have the same thing on the other side. We have an x length, which I'm going to try to make sure is about the same length as that x. And then we have 3. Make sense? It's a bit long. And then we can finish that box off, because we know it's supposed to look like a square. And we're going to take this dotted line that shows x all the way down to the bottom. And we're going to take this dotted line across, all the way across. Under where it says, with a grid. And now, you can see exactly what happened. We created all of these divisions, all of these little areas, where this area represents x times x, which is x squared. This area represents 3 x's. This area down here in the bottom left also represents 3 x's. And what about this bottom right corner? What does it represent?
Ones.
Ones. How many ones are there?
9.
There's 9 ones. 3 times 3. So here we have x squared plus 3x plus 3x plus 9, and that reduces to x squared plus 6x plus 9. Okay, something that you need to notice. What's going to happen every single time we draw a grid like this? What's going to be the same? What's going to happen with these two boxes? They're both going to be exactly the same. So what we really have here with 3x plus 3x is we have 2 3x's. Well, where did this 3x come from? The first two terms of our binomial. Okay, I should use this one. The first terms of our binomial. X times 3 times 2 equals 6x. Okay, let's show it algebraically and then we can carry on. Show it algebraically and then we can carry on. We've got x plus 3 squared. x plus 3 squared. Well, that's equal to x plus 3 times x plus 3. If we were going to FOIL this, which we are, we would get first times first is x squared. Outside times outside is plus 3x. Inside times inside is plus 3x. Last times last is plus 9. Looking closely at our terms, we notice that we have 3x twice. So I'm going to write it the same way we did before. We're going to have 2 times 3x plus 9. I'm just showing you the pattern with numbers, and then we're going to write the rule for it. So now you can clearly see that every single time you do it, you're going to have 2 times a times b, or 2 times b times a. It doesn't matter how you think of it. But we have the two terms from our binomial times 2. And this reduces to x squared plus 6x plus 9. Okay, let's write an official rule for squaring binomials. Okay, an official rule for squaring binomials. The rules are these. There's 2 of them. When we're dealing with squaring a binomial and there's addition in between the terms in the binomial, the resulting product is a squared, it's just the first term squared, plus 2ab plus b squared. If you have a squared binomial and there's subtraction in the middle, it's just a squared. And this time, the middle term is going to be minus. It's going to be subtraction. So it's subtract 2ab. The last term is still going to be plus b squared, because if you take a negative times a negative, you get a positive. Right? So it's still going to be plus b squared. There's your 2 patterns. If you can memorize that, you will do well. This happens, this comes up all the time. It'll come up again in grade 11, and you'll be able to recognize, oh, that's a squared binomial. Oh, that's a perfect square. Trinomial, those things, okay? This side is called a squared binomial. The right side is called a perfect square trinomial. You do need to make sure that you get this, because it comes up really significantly in Unit 6 as well.
Just say square trinomial.
Next unit.
A square trinomial is probably sufficient, but you should get used to perfect square trinomial, because that's what it's called. Just like you're called Tanner. Can't change your name to Banana. Wouldn't make any sense. It still kind of sounds just like Tanner, but it's not quite the same.
That sounds not correct.
Good. The resulting products are called what? When you take a squared binomial, what's the resulting product?
Perfect square triangle.
Go ahead and write it in the blank. In the last examples, we were dealing with a binomial squared. This is going to be another special case, quite related to that one. In this case, we're not dealing with a binomial squared, but we're dealing with conjugates. You don't need to know that word. It just means that you have the terms a and b in both brackets, but one of them they're connected by addition and one of them they're connected by subtraction. Okay? This is called the product of a sum and a difference, because this bracket is a sum, x plus 3, and this bracket is a difference, and they're being multiplied together. So the answer is going to be this statement is the product of a sum and a difference. Okay? That's where it gets its name from. The resulting product is called the difference of squares. Okay? I'm going to show you the resulting product. It's x squared minus 9. This is called... Okay, that one's done. See you later. Difference of squares. How do you think that one gets its name? Difference of squares. Do you see a difference symbol?
Yes.
Yeah.
Subtraction.
This is difference. Do you see any squares?
Yes.
Where?
It's X squared.
X squared is a square. Is 9 a square?
Yes.
Yes.
Front page of your notes says that 9 is a perfect square number. 3 times 3 is 9. So these are both squares, and there's a difference in between. So the difference of squares is equal to the product of a sum and a difference. Okay? To find the product of the sum and the difference of two terms, so to simplify this to this, here's what you do. You find the product of the first terms and the product of the second terms. So all we have, I'm going to generalize it. This goes under your rule column. You've got a plus b times a minus b. And all we need to do is find the product of the first term in each binomial. That's a squared. And the product of the second term in each binomial. That's b squared. And we need to have a subtraction in between there. It's called the difference of squares. I'm going to show you exactly why it works going back up to our x plus 3 example. So, let's see why it works. X plus 3, x minus 3. And if we FOIL this out, we get first times first is x squared. Outside times outside is negative 3x. Inside times inside is positive 3x. Last times last is negative 9. Look at what happens to these middle terms. The O and the I. They're 0. And all we're left with is x squared minus 9. Which is the difference of squares. Get it? Got it? Excellent. Ladies and gentlemen, example 1 has 5 parts, 5 algebraic examples and expressions that we need to simplify by applying special product patterns. We're going to apply. That means use. In order to use, we first need to identify. So, here we go. I'm going to write number A. A is x plus 4 squared. Can you identify anything special about that? What is it? It's a binomial squared. It's a binomial squared. Okay. So I think that means that it takes the pattern a plus b squared. And we have a pattern. We have a rule for that pattern. Double check your sheet. What's the rule for squaring a binomial?
A squared minus b squared.
Where they're attached by addition.
No, it's square.
X squared minus 1.
A squared plus 2ab plus
It's the result is going to be a perfect square trinomial. It's going to be in the form a squared plus 2ab plus b squared. So don't look at your sheet and find something different than that and then say, oh, that's what we're doing. You're not doing that. Find the right one. Okay? Well, this is really straightforward now. All I need to do is put my information, my a and my b, into my pattern. So this tells me that x plus 4 squared is going to be equal to my first term squared, which is x squared, plus 2ab. That means 2 times x times 4 plus my second term squared. Well, that's just 4 squared. Make sense? I've just taken the pattern and put in my values for a and b. And now we can simplify. First term is x squared. Second term is 2 times 4. 8 times x. 8x. 4 squared. 16. This is a perfect square trinomial, and what you have done is you have squared the binomial. Yay! Hurrah! Okay. Good job. B. Here comes another one. We've got k minus 5 squared. Find the pattern.
a minus b squared. So is it h of a? So a squared minus.
Okay, so it's a binomial with subtraction in the middle. It's the difference of two terms.
What is it?
Flip back to your first page. Find the rule. Find the pattern.
Oh.
So we have another perfect square trinomial, but this time it's in the form a squared minus 2ab plus b squared.
K.
That's a, Mr. D, is that a 1 or a K?
It's a k.
Clearly K.
Okay, so we have a is k
Why'd you plus,
and b is 5,
why'd you plus the B?
because that's the rule. Because this would be negative b squared, which is negative times negative is a positive. Yeah? Okay, so we've got k minus 5 squared, and a is k, so this one is just k squared. And then I have minus 2ab, so that's minus 2k5. Plus b squared is just 5 squared. I'm just filling in blanks using my pattern.
Question. Would it still be positive 5 even though it's a negative in the...
Would anyone else like to answer that question?
Yes, because a negative times a negative is a positive.
It's a good question. So Paul's asking why, and Vlad asked the same question. He said, why is this positive b squared? Well, let's look at what happens if we take negative b and square it. Positive b squared. Okay? Alright, next step. K squared. You go ahead and do the middle term, please. 2 times 5 times k. Should have minus 10k.
Yeah.
And the third term, 5 squared, 25. Done. Okay, C. C is 3y plus 7x. 3y plus 7x squared.
Ooh, that's too hard.
What do you do?
What do you see?
What are you doing? An X and a Y?
What do you see?
Okay, what pattern do you see?
Plus. So
It's plus,
a squared plus 2ab.
so it's just a plus b squared. That's all it is. It's a binomial. There's two terms. Here's a term, here's a term. So 3y is a, 7x is b, and we're squaring it. So the pattern's the same as a that we did. A squared plus 2ab plus b squared.
So this time instead of like a x squared would be 3y squared.
Okay, let's plug it back in. 3y plus 7x in brackets squared. Well, a is my first term. What's my first term in this binomial? 3y, and it's going to be squared, but make sure you don't just square the y. You have to put it in brackets, and you have to square the whole thing. That means you're squaring the numerical part of the term as well as the variable. Alright, then here we have 2
Is it always 2?
times ab. It's always going to be 2ab. So a is 3y, and b is 7x. And then we have plus 7x, and that whole thing gets squared, the 7 and the x. Okay, 3y squared is 9y squared. If you've been contributing a lot, then pipe down a little bit and let someone else have a chance. Here we go. 2, and remember, these are 3 and y, they're attached by multiplication. 7 and x, they're attached by multiplication. But this whole bracket is also attached to that whole bracket by multiplication. So everything in here is just multiplication, which means you can rearrange it any old way you want. So you can do 2 times 3 times 7, which is 42. And then you have times x times y. So good. So you'd be at 42xy. Make sure your x doesn't look like a multiplication sign or you'll lose it. 7x squared? 49x squared. Yep, x is 2. X times x.
Because it's a square.
That's okay. It's a really simple rule. All you have to remember, like we said each time already, so don't look at Isaiah when you ask a question. Look at the board? Yep. Good. 7x squared means that you have to square the 7 and the x.
What?
Because this really means 7 times x times 7 times x, which I can rewrite as 7 times x times x. Here I have 7 squared. Here I have x squared.
Why does not the square not go away though?
Do you know what x is? X is x. Could be anything. It's a variable. Okay, so whatever x is, you know that you're going to be multiplying it by itself. So you have to leave it as x squared. You can't make up what x is. Okay, good. I'm going to clear this. We're going to go to D.
That's the answer? D, there's no room for
D. A minus... D is Q minus 11. Q plus 12. What do you see? Sorry, Q plus 11. Obviously, they got to be the same.
We have both.
Okay, so we have A and B. They're the same. Q and Q, 11 and 11. And then we have both subtraction and addition. Do we have a pattern for that? A plus B times A minus B.
Is it squared?
The product of a sum and a difference. What does the product of a sum and difference equal?
Perfect
Square
trinomial.
A difference of squares. So this is going to be A squared minus B squared. Alright, so I'm not going to rewrite the question of Q minus 11 times Q plus 11. We just know that A is Q, so it's Q squared. And we're going to be minus 11 squared. Anyone know what 11 squared is? 121. Good job. And E, our last example under example 1. E is 4m plus 3n times 4m minus 3n. What do you see? What? It's the same thing, right? It's a binomial. And one is a sum and one is a difference. So it's the same pattern as up here. So this is going to equal a difference of squares. A is 4m, so we're going to have that squared. And it's a difference. And B is 3n. We're going to have that squared. Vlad, can you please square 4m for me? Remember, the number and the variable both have to get squared.
16m squared.
16m squared. Good. Tanner, can you please square 3n for me?
9n squared.
9n squared. Good job, guys.
What if you have,
You got it.
What if you have n and n on the same, like 4 and n?
Yeah, then that would just be A, and you'd go from there. Yep. You could have multiple variables inside A or inside B.
What if you have squared
Okay.
and 4n?
Welcome to the helicopter pad. We're going to take a trip over the falls and see the water coming over the falls and the beautiful landscapes. But first, we need to be able to land on the helicopter pad. And for that to be true, the helicopter pad has to be the right size. So we're going to have to learn about it a little bit. The radius of a circular helicopter landing pad is increased by 3 meters. It wasn't big enough, so the radius was increased by 3 meters. Well, let's draw a picture of what that might look like. Let's say we have an old helicopter pad. I'm going to draw it a bit bigger. And the radius right here is going to be increased by 3 meters. So the new helicopter pad is going to be about like that. So I know that we've added 3 meters. And I don't know the original radius, but let's just call it R. So the new radius is what?
3 meters longer. So it's r plus 3.
So an expression for the new radius would be R plus 3. Okay, let's see what we actually are supposed to do. A, find a simplified expression for the area of the new circle. Oh boy. Let's talk about the original circle first with radius of R. What's the equation for the area of a circle?
Pi radius squared.
Area equals pi r squared. Good. In A, we need to find an expression for the area of the new circle. Well, what is r in the new circle?
3.
It's not 3, it is r plus 3. So now we have pi times the radius, which is r plus 3, squared. Do you see how our examples so far are coming in handy right now? Okay, it's a direct application. This isn't done yet. Okay, we need to do some work here. But we know this is a pattern, right? R plus 3, a plus b squared. So if we have our patterns memorized, we know this is just a squared plus 2ab plus b squared. So we've got pi out here. And then we've got r squared plus 2 times a times b. Well, all I have to do is 2 times 3 times r. That's 6r. And b squared is 9.
I go to find someone.
Now, we need to distribute pi to each of our terms. So we end up
3
with
plus 1, 4 squared.
pi r squared plus 6 times pi times r plus 9 pi. Pi is not equal to 3.14, so don't do that. Okay, B is a little bit tougher. B says, okay, now you have the expression for the area of the new circle. Can you find an expression for the increase in area? We're looking for the difference between the big circle and the little circle. Okay, we can obviously see the big circle has a bigger area than the little circle. But now we need an expression for the difference between the two areas. So we're going to get the expression for the increase in area by finding the difference, the area of the big circle minus the area of the small circle. Can we agree that that would equal just this outer distance? Wonderful looking orange donut. Safety cake? Is that safety?
Cake.
I like cake better. Okay.
Safety cake, that doesn't even make sense.
The area of the big circle is what?
Cake.
It's right here, right? Area of our big circle. So pi r squared plus 6 pi r plus 9 pi. And what was the area of the smaller circle?
3. 9.
Pi r squared, right? Radius is r, so area is pi r squared. So we can bring that guy down. We're subtracting pi r squared. Oop, 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 oop. Okay? Because we're finding the difference between them, which we established right here. Good. Do you see any like terms? We have an r squared term here and an r squared term here. They actually just cancel out. Pi r squared minus pi r squared. So all that's left is 6 pi r plus 9 pi. Okay, so we used our patterns to help us with an application. It looks messy because it has pi in it and a variable, but pi is really just a value, it's just a number. And if we keep it organized, we bring it down, we can simply come up with the expression.
Why do we have 2 A's?
Yeah, why do we have 2 A's? Good question. That's B. Good. Your homework is listed for you at the bottom of the page. Please come tomorrow with questions.